Question 3 is all about the discriminant. So we are given a function here, and we are asked to show that the discriminant of the function is 100 minus 4p squared. So it's, we're starting by just writing down the general formula for the discriminant. So the discriminant, remember, is b squared minus 4ac, and that's referring to a, b, and c in the general form of the quadratic ax squared plus bx plus c. So in our function here, we can see that a is going to be the coefficient of x squared, which equals p. B is going to be the coefficient of x, which equals 10 minus p. And c is actually going to be the constant term at the end, which is 5 over 4p minus 5. So substituting those into the discriminant up here, we get b squared, which is going to be 10 minus p all squared, minus 4 times a, which we said is p, times c, which we said is 5 over 4p minus 5. So if we expand 10 minus p squared, we're going to get 100 minus 20p plus p squared. And then we're going to have negative 4p times 5 over 4p is going to give us negative 5p squared. And then we're going to have negative 4p times negative 5, which is going to give you, plus 20p. So therefore, the negative 20 and the positive will cancel out, and we will be left with 100 minus 5p squared plus p squared, which is going to give us the minus 4p squared that we are asked to show in the question. Find the values of p such that the function has two equal roots. So if we're interested in two equal roots, then it means that the discriminant up here is going to be equal to 0. So we've just shown that the discriminant is equal to 100 minus 4p squared. If we want two equal roots, we know that the discriminant will be equal to 0. So 4p squared will equal to 100. P squared will equal 25. Therefore, p is going to equal plus or minus 5.